Good afternoon, everyone. Matt from Coin4DBot. I just wanted to come out to the studio, talk about some things I've got in the works. Been cutting some new dies for Port Royal Reserve line, and I'm pretty excited about that. I'm going to try to take what would be commonly known as a poured button or poured round, fabricate a collar so that when I press it, it makes a uniform rim, more like a finished coin, but definitely not looking like a regular struck or stamped button or round. So I'm pretty excited about that. I've got that in the works. I've poured a few buttons, some proof of concept, R&D type of stuff. There's a few of those right here. Look at how nice those came out. These are 5 ounce, 3/9 plus. Now, little industry trick. These rounds or buttons, a lot of times, are produced in what's called a flameless tunnel. A flameless tunnel is nothing other than a horizontal induction furnace or induction coil with a pusher and a track. What happens is they preload molds, whatever increment of weight, set a cycle and power, and then the pusher and the furnace works off of that to make a consistent and continuous melting of whatever increment of material you're doing. So if it's all 5 ounce rounds, if it's all 10 ounce bars, if it's all 20 ounce bars, it just keeps pushing and pushing and pushing. And essentially, because it's under atmosphere and it's induction furnace, the blanks or the rounds come out almost perfect every time. The only time that would interfere with that is if it was material with a higher trace impurity content or some metallurgical discrepancy. But for the most part, if you use good quality grain, 3/9 plus, 4/9, low trace impurities, selenium, bismuth, it's going to come out pretty much looking like this. Now, the trick that I use to do this, and everybody can do this at home as well, is if you have a little box furnace or kiln or muffle furnace, you can use a Forstner bit, which is these. Get some really high quality graphite, blanks, bars, however you want to order it, and you can take these Forstner bits, I don't know if you can see those, and I grind off the nipple. See how some of them are ground off of it. Put it in your drill press. This one happens to go from 1 inch to 2 inch and everything in between. And then you can buy, there's obviously smaller ones. So you could even, so essentially you can go from making 1 ounce rounds, blanks, all the way up to 2 inch round blanks, which is what this is. These ones that I made right here. These are 2 inch round. You can see it. Not quite 1/4 inch. But you can get a piece of graphite like this, get your drill press, and you can make as many round molds as you need. Now, you might say, okay, I pour mine with a crucible ladle, or I use a static caster furnace, graphite crucible, and I pour it into my molds. That's all fine and dandy. The issue is that if you do this, see, I could have even fit more on this piece of graphite. I could pour up to 20 buttons or 20 molds in a matter of a couple hours, if not more. I've got about 3 furnaces. I can load all those up. I can stack 3 molds in, and I could have 12 to, depending on the size of the increment I'm trying to do, I could have 12, I could have 4, I could have 6. You stack those molds 3 high in there, have 3 furnaces doing that. Potentially you could do 20, 30 buttons or rounds or even bars. If you have a machining center, you could machine out square blanks. So now I want to caveat that with, you have to have a furnace that can go to at least 2050 Fahrenheit. 960 Celsius, which is about, let's say for ease of remembrance, is about 1800 degrees Fahrenheit. So 960 is liquidus for fine silver. 960, which is approximately 1800 degrees Fahrenheit. Now, there's a huge difference between the liquidus point or melting point and fluid. So, of course, you have a furnace that goes 960, 1800 degrees Fahrenheit. It's gonna melt, but it's gonna take a long time. It's gonna have to stay at peak temperature for a while to do that, and you're not necessarily gonna get the fluidity of the material if you pour it, or if you're trying to fill a mold that would be fluid enough to uniformly fill the area, especially if it's something, I don't know, it has some fine edges or points. You're going to want that material to be as fluid as possible to fill into that desired shape. So I would say a minimum box furnace of 2050. Let's say 2000 to 2050. You'll be safe. And most of those do that. The small kilns, the paragons, the little muffle furnaces, the box furnaces, all that. So, moving on. And that's how all the big mints do it. All of the poured cast bars that are advertised like that, they're all done with a flameless tunnel. And it's merely, like I said, a horizontal induction furnace, which uses, induction furnaces use an electromagnetic field to force the atoms in the material to move and melt. And it's a rapid melting of metals and material. Now, the little static casting units that most people use and they pour, that's referred to as static casting. You've got continuous casting, which is a crucible with a volume of material that melts at a certain rate, and you're extracting material at a certain rate as well. So you're filling and pulling all at the same time. Now obviously that doesn't happen fast, but you can time it to where it strokes and pulls material, and you add material to counter that temperature and counter the way that the machine pulls to make it to where it's almost perfect. No loss in temperature, adding and pulling, and you can go on and on for days. So, with that, I wanted to get into the little buttons I made. Like I said, these are 5-ounce rounds, 2-inch round, 3/9 plus. And we're going to get into, I cut some new dies. I don't know if you can see that. Casa de Moneda, Port Royal Reserve, 1692. C for D, coin for D bot logo in the center. That'll be the forward. The reverse will be a lasered logo design with maker and increment. And I went through a process of polishing this up. All of these dies start with cold rolled round steel, cut and then sanded, usually from 80, 120 grit, all the way up to about 5,000-6,000. Then they're lasered to depth, lasered to what I think the required amount with force of the presses that I use to get a good ideal impression. Then they're heat treated and oil quenched, cleaned, polished again all the way up to 60,000 grit using diamond paste and a polishing wheel. And it's just a long process. Add, polish, clean with alcohol, add, polish, clean with alcohol, put it in the ultrasonic cleaner, let it sit for a while, go back, check it, and finally you get a good result. And it's kind of a mirrored finish. I don't know if you can really see that, but that looks great.